To solve this word problem, I know the printing's rather small for you to be able to read this, so I'll kind of say it and rewrite what we need. But if the cost C for manufacturing X units of a certain product is given by this equation, C, we're going to plug in cost there, x squared minus 10x plus 40. Find the number of units manufactured at a cost of $10,015. Okay, so the formula that we're working with is C equals x squared minus 10x plus 40 and we're told that cost is C. The cost is $10,015. So instead of a C, I'm going to plug in 10,015. So here's 0, 0, 1, 5. And what's supposed to trigger your strategy, so to speak, is you have a trinomial with something raised to the second power. You're hoping to get this into factored form. If you can have this in factored form equal to 0, then you can solve it using our zero factor property. So you certainly don't have a 0 on the left side. So we're going to subtract 10,015 from each side. When we do that, we have 0 equals x squared minus 10x, and here if we do our calculation off to the side, get rid of the 40, what are we left with? That's 11, 9, that's 7, 9, 9. So we will be left with a negative 9,975. Okay, and then we're going to see if we can factor this polynomial. Using our rules for factoring, there is no GCF. You don't have 2 terms, you have 3 terms. The leading coefficient is a 1, just as here. Whoops. Just as here. So, all we have to do, and I use that term somewhat sarcastically, is list all the factors of 9,975 and choose the 2 factors that will give us a difference of negative 10. Except there's an awful lot of factors. So we're going to need a bit of a strategy here. Whatever factors multiply to give 9,975, those factors are comprised of the prime factorization of this number. So let's come up with the prime factorization for 9,975. 9,975. Notice it ends in 75, so 25 will go in there. I think I better start using a finer point pen. So to find out, let's see, I know 25 will go in there. Okay, so that's to say I know I can have 25 times something and it will work out. So let's see what that is. 25, 9975, it goes in there 3. Bring down your 7, it's going to go 4, 8, 9 times, and that'll be 225, and again 9 times. Okay, so 25 times 399 is 9975. Prime factors, well, 25 won't be hard to finish out. That's just going to be 5 times 5. Okay, 399, well, that's a little trickier. Notice 3 divides into it. So 3 times 133, and that might look like a prime, but we got to check pretty carefully. If this was the prime factorization, I'd have some combination here that would give me two factors with a difference of 10, or at least that's what I'd be looking for, and so far I don't see it. So I'm going to take a real close look at 133. 2 won't go in there, 3 won't go in there, 4, well, if 2 didn't work, no even number will work. So let's go. 5 won't work. 7 would be the next thing to try. You just kind of go up the line trying your prime numbers. So 7 into 133. 7 goes into 13, well, once. What's that? 6, bring down your 3. 7 goes into 63, 9 times. Okay, so this 133 can be broken down a little more. 7 times 19. Alright, so we now have the prime factorization of 9,975. It's 5 times 5 times 3 times 7 times 19. Okay, if I have two numbers that multiply together that give me 9,975, those two numbers are comprised of all of these prime factors. None of them can be left out. So I'm basically looking for what combination of these will give me a difference of 10. So I know I want them both to be kind of big. Let's see, 7 times 19, we figured that was 133. 5 times 3, 5 times 19 is close to 100, so I'm going to pick that. 5 times 19, so if I use that and I use that, 5 times 19 would be 50, that would be 90, okay? And then I'm left with a 5, a 3, and a 7. How to do it? 5 times 3 is 15 times 7. Darn, I'm 7, 21. 21 times 5. It'll end in a 5. I kind of like that. That's 105. Okay, so that was 3 times 7 times 5. So I've used this one, and this one, and that gave me 105. Alright, forget about the 90, that wasn't working. So I have 105, and what's left? A 5, put a box around that, and a 19. 50 and 45, so that's 95. And look, we can have a difference of negative 10. So the prime factorization of x squared minus 10x minus 9,975. The first term wasn't much of a mystery. That was simply an x. For this to be negative, we had to have, I'm not even sure where to show it, we had to have positive times negative or negative times positive. Okay, that's the only way you can get a negative product. So the signs are different. That means I want a difference of negative 10. It must be that the larger one is negative, the smaller one is positive. So I have minus 105 plus 95. And this is all equal to 0. And now we use our zero factor property. If you have something times something equals 0, then one of these two sets of parentheses must be equivalent to 0. Maybe both of them are. Okay, so we simply break them up and we say x minus 105 equals 0, or we grab the other one, x plus 95 equals 0. You solve each one for x, plus 105 plus 105. So x equals 105, and minus 95 minus 95. X equals negative 95. Now let's see if these make sense. They want the cost for manufacturing units of a product. Find the number of units manufactured. Well, we couldn't manufacture a negative 95 units. So even though we got to this answer legitimately, you basically toss it and you hang on to the positive value in this case. So we manufacture, if you manufacture 105 units, it will cost $10,015. So your answer is simply x equals 105.